Hello. In this episode of Hydra Coding Challenge, I'm not going to go to do a challenge, but instead I will respond to some of your comments, feedback. And first, I want to start with this sketch sent from Seb. Thank you so much for watching and also making this sketch. Um, I don't know if exactly which episode or if he's inspired by something else, but I really like how these different layers and colors overlaying on top of each other. And it's really interesting how these lines that looks a little bit different from how you see Hydra, like it's more geometric, let's say, in the sketch, that I also kind of try to recreate in, for example, recoding Casey Rios. And yeah, I really like to look into it deeper afterwards. But thank you so much. And of course, like if you, like other people, if you make any interesting sketches, please send it to me so that I can showcase in these videos. And there's another question from Computational Mama who was asking about the usage of R function. And that's kind of the tricky one. I explained, okay, so I will just use this here. So R is a bit of a mysterious function, and the way how it works is it replaces green, blue, alpha channel with red channel. So it doesn't really explain well. Let's see how what it does. So for example, if you have what would be nice one, gradient out, and then in gradient, what happens is that if you go towards the right, well, look this way because I'm mirrored, to the right, it becomes more red. Towards the bottom, it becomes more blue. And it's also like a combination. So if you go to the right bottom, then it becomes yellow because it's a combination of red and green in terms of color. Of course, if you think about paint, it's the opposite. If you mix more and more and more, it becomes darker and darker and darker. It's more subtractive. But in the terms of light, it's more additive. So if you add, like mix red and green, it becomes brighter. And of course, if you mix blue on top of it, it becomes white, which is actually just because of the perception of human eyes, and it's not actually messing up with the color spectrum, but that's another topic. So in the computer, oh my gosh, that's like another rabbit hole. So let's not go into it. So let's just say red and green in gradient. Also, if you add one or two or whatever, let's say one, as an argument, which defaults to 0, so that's why we don't see any blue color. But if you add parameter, then it will add blue on top of the gradient, which is also interesting if you want to make some kind of animation with this. And now let's go back to R. So what happens if you just add R to it? So this is surprisingly very uninteresting. And what you can observe is it's from the left side, it's completely black. And towards the right side, it becomes brighter, brighter, brighter until it hits the edge when it becomes completely white. I mean, it's 255, 255, 255 or whatever. And why is this happening? So what if I do G, which stands for green, and takes the green channel? And what happens is that, as I said, in the original gradient function, the bottom is more green, the right is more red. So if you add, that was not a good way to do it. Okay, G, then it becomes brighter on the bottom side because G takes the green channel, extract the green channel, and replaces red, blue, and alpha. So what happens if we do B, which is blue? Black, because there's no blue color in this case. But again, if I add a parameter which is not 0, then you see that it's actually, what it does is adding blue color uniformly to the whole texture. And this, with this, there's no like which part is more blue, which part is less blue. It's just uniformly adding blue to it. And just out of curiosity, if you add A, which is alpha, you can guess. I would say it will be something completely black or completely white, but I know the answer, which is completely white, because A stands for alpha, and if there is no alpha, then even if it has like different RGB colors, it will not appear, because that's what alpha is, like transparency means. And actually, this is something interesting to look at. So if you do like OSC, like A is alpha, and it's always alpha is there. Noise, there's always alpha. Voronoi, there's always alpha. What else do we have? I mean, solid, it's a little bit tricky, different, so I would skip, but shape? Shape always has alpha. Like shape has, let's say in this case it's triangle, and if you do R, then it's the same, although it's slightly different. What is different? So if you do this, nothing changes. But if you skip R, it's completely white. So this is, sorry, this is making it a bit confusing, but most of the sources in Hydra has uniform alpha, which means, so it means that shape has uniform alpha of 1, which is opaque. Even if it's black part or white part, it's opaque. And what if I have OSC and then layer a shape on top of it? You don't see nothing, because the black part is opaque, so it just overwrites the OSC pattern. And probably most of you know that if you do luma on top of shape, then you can see something in behind. This is one way to do to introduce alpha. And for example, if I just skip this, again, this doesn't change much from the original shape, but again, you know that this has alpha. And if you do A, you can verify that it does have alpha, because if I don't do luma, it's opaque. Why am I doing this? Okay, so we'll go back to OSC. So what's interesting here is that if you do luma, you can layer something on top. Something a bit problematic with luma is that if you take, for example, OSC, well, this doesn't make sense, so I'll just probably flip them so that shape is, so now it's the opposite. You have the shape behind, and I put OSC with luma. And this is okay if you want something like this. But then what if I like want like, so this luma is like a threshold, right? It's, and again, threshold is different. Thresh is different because thresh is always opaque. Luma is not opaque. It's more like a luma keying. Like bright color appears, darker color will be 0 alpha. But that's probably like, sometimes it's not really good or like not ideal if you don't want to like complete the threshold. Like this is like almost saying that, I forgot the exact parameter, but something like this, which means, or a bit bigger, something like this probably. It means that the darker color, darker than 0.5, will be 0 alpha, and the brighter one will be alpha 1. But what if you want something more like a gradient? Like OSC is like sine wave. It has values in between. Like it's not like 1 and 0. It has 0.9, 0.8, 0.7. What if you want alpha to be gradient? And here comes R function. This is actually very interesting because now it still has the transparency, still has this overlay effect, but it's very blurry. That is because our function is taking our value. It doesn't have to be r. In this case, it can be g, it can be b, because it's white. So just taking one of those RGB values of OSC, and of course OSC, as we saw, alpha is like completely one uniformly. It's opaque. But if you use R, G, or B, then it will replace the alpha channel of OSC with one of these values, which results in alpha value from 0 to 1. And it's very different from Luma because Luma is more like thresholding. If it's bigger, then it's 1. Smaller, it's 0. But if it's R or G or B, then it has continuous values because of OSC. Out of curiosity, Voronoi, again, it becomes like kind of a, half transparent. And probably noise will do something very strange. Not so much. Because noise has values from -1 to 1, but that's another thing. And of course, I can do shape. Well, you wouldn't see a difference, so I would change it to maybe something like 5. In this case, like shape is like almost like black or white. So this looks like same as Luma, almost. But what if I want a blurry shape? Something like this, like the last parameter. So the second parameter of the shape is the size of it. And the last one makes it blurry, the edge. And if I do this, as you can see, or maybe I should just change it to OSC, the background, you can see that it's something very interesting, that it's overlaid on top of OSC that is blurry, which is very difficult to do with Luma. It becomes, oh, this is actually an interesting effect. It's more, the boundary is more visible. Of course, you can do something like 0.5, like this second parameter of Luma bigger to recreate similar effect. That is also possible, but usually I use R because it's simple and I can kind of predict the effect better. So that's that. I don't know if there's other ways of using R, G, or B. Maybe one thing I would say is, for example, if you have OSC out and modulate scale. I'm not going to go into what modulate scale exactly does, but for example, if you do gradient dot R, creates really interesting effect that it stretches like a perspective. Or it's clearer probably like with a shape 4, something like a, yeah, it's like a perspective effect. And this doesn't happen if you skip R. Maybe I should make the shape a little bit smaller so you can see the effect. This is nothing interesting, but if you do R, somehow it makes this effect, we can make it harsher, like this. And of course, if you change to gradient G, it makes the other way around. And if you want to flip it, probably you can just do invert, or you can do scale to make it upside down, and so on. So this is another way of using RG. In this case, not B, but RG function, because it makes something really interesting. So I hope this answers the question. I mean, still, I think it's kind of, you have to go into like math a little bit, like what's happening behind. But also, like, you can just say, yeah, I just like this line, so I just remember that and just use it. I think that's completely fine. Or the other one, the layer shape .r, it works. So why not? And yeah, but if you have more questions, please write in the comments or send me email or whatever. And the last thing I want to show you in this video is something a bit nerdy thing that I made. So in the last two videos, I recoded Rosamund Inkelman's works. And one thing I was really interested was her research in resolution and also compression and like image formats and so on. And there's this idea called discrete cosine transform, which is not invented by her. It's invented by computer scientists, I guess. You can search about the history of discrete cosine transform. But basically, what it is that it's used for JPEG compression, and it basically takes 8x8 matrix or 8x8 pixels of the image and convert it into a combination of cosine or sine. It's basically the same thing with a different phase, and kind of it expresses 8x8 matrix in a simpler form, or more like just takes out some of the details, but it still looks same for human eyes. And that's why JPEG makes the compression really good. This file size becomes super small because of this trick. And I knew that it's just math behind it, and you can convert any kind of 8x8 matrix into combination of sine waves, which sounds really nerdy. So I made this editor, which has here, I have this 8x8 checkbox that when I click on it, it's actually generating a bunch of OSC, add OSC, rotate OSC, but it's basically all the sources are OSC, and it's combining different OSC with different phase, different frequency on top of each other to recreate this matrix as a Hydra function. So if I do this, for example, a bit simpler, you see like a 2x2. It's not, doesn't look 2x2, but light, brighter part in the middle. And I can just tweak it like this. And I also made a function or a feature. So this looks like more like OSC actually, that kind of makes you feel, yeah, it is actually made of OSCs, which I think is really cool. And I added like different, introduced glitches to these functions. I think if I actually show the, I know, in the inspector I don't have it anymore. But I have like huge, like long line of Hydra code, which is like OSC, add OSC, color OSC, rotate OSC. And here I can add this animation thing, which looks like kind of combination of OSC, right? But then if I mess with the function, it becomes really abstract, which looks kind of funny. Plus, I added this feature to shift the color, which is completely like, it's nothing to do with discrete cosine transform, but it's just adding another parameter to the discrete cosine transform so that it becomes something else. And I just want to show you this because it's kind of also another recode challenge, which I couldn't do it in the video because it took quite some time to code it. But just using Hydra in other way that is not just making pattern on your own, but recreate something as a reference to something that already exists. It has actually rich history of discrete cosine transform and the JPEG format itself. So to me, that's really exciting. I don't know how you feel, but also like if you want more explanation of what's happening behind, feel free to write to me. Maybe if I get requests, I will make another video, but I'm not sure because it's like I'm also not like qualified to explain anything about this like digital signal processing stuff. Although I know like a bit of basics, but let's see. I don't know what people are interested, but just feel free to write to me, and then hopefully I can resume this coding challenge series in the near future. And yeah, I keep looking at looking for what's interesting to try next, but it's not. Hopefully, it's not that too difficult for me to recode. Anyways, so thank you for watching. Please like the video. If you like it, please subscribe. I really appreciate everyone's help, and hopefully see you in the next episode very soon. Bye.